You know that feeling, right? You're deep in a project, things are finally clicking, and you just take a little shortcut. You hardcode your secret keys right into a config file. It's fast, it works, and oh man, it is one of the most dangerous things you can do. Let's unpack why.
Okay, take a look at this. It's a super common config.py file. But you see those two lines? The AWS access key ID and the AWS secret access key? Yeah, those are literally the keys to your entire kingdom. Anyone who gets this file can walk right into your AWS account, spin up resources on your dime, and poke around in your sensitive data. It's a ticking time bomb, and it's just sitting there in your code.
So you've wrapped up your feature. You're feeling good, and now you're ready to share your masterpiece with the world. Maybe push it to a public repo on GitHub. What do you think is going to happen when you try to upload that little ticking time bomb? Let's find out.
So our developer, totally focused on getting the app to just work, has done exactly this. And for a quick local test, hey, it seems harmless. But this is where the story takes a turn. Here's the thing you have to remember. Hardcoding isn't just a bad practice. It is a massive, gaping security hole. The second that code hits a public repository, anyone, and I mean anyone, can just browse your files, copy those keys, and have full access to your AWS account. It completely bypasses every other security measure you've got.
So our developer is about to make this exact mistake. They're all set to push their code, secrets and all, straight to their public GitHub. They pop open the terminal, ready to go live. Let's watch what GitHub does.
And here we see the classic workflow. First, git add to stage everything, including that dangerous config file. Then, git commit to take a snapshot. And finally, the moment of truth. Git push origin main. The command is sent. What happens now?
Nope, rejected. The push is totally blocked. But why? Well, GitHub has this amazing automated secret scanning feature. As the code was being uploaded, it scanned for patterns, instantly recognized the format of an AWS access key, and slammed the brakes on the whole operation to stop a leak. It's like a built-in guardian angel for your code.
Okay, so if hardcoding is a definite no-go, what's the right way to do this? Well, this is where the hero of our story comes in. AWS Secrets Manager. This is the professional, grown-up solution for handling sensitive data. Put simply, think of Secrets Manager as a secure digital vault up in the cloud. Instead of sticking your passwords and keys in your code, you store them safely inside this service. Your application is then given just enough permission to ask for those secrets at runtime, right when it needs them. Your code stays clean, and more importantly, your secrets stay secret.
And it's so powerful because of a few key things. It doesn't just store your secrets, it encrypts them. It lets you use AWS IAM to control exactly who or what can get to them. It can even rotate your credentials for you automatically, which is a massive security win. And maybe best of all, it's built with developers in mind.
I mean, just look at this. To make your life as easy as possible, the AWS console gives you ready-to-go code snippets in Python, Java, Go, pretty much any language you'd need. You can literally copy and paste the logic right into your app. It's all about making it easy to do the right thing.
Okay, so let's actually put this into practice. We're going to refactor our original app, we'll rip out those hard-coded keys, and replace them with a secure call to Secrets Manager.
And here it is, the grand transformation. On the left, you've got the old, dangerous way, with credentials just sitting there in plain text. And on the right, the new, secure version. The secrets are totally gone, replaced by a function that fetches them from AWS when the app starts up. This is what secure code looks like.
So, how does this new code actually work? Well, it uses Boto 3, which is the AWS library for Python. And it makes a simple call to a function called get_secret. That one function handles all the secure communication with AWS, grabs the secret we stored earlier, and brings it back for our app to use. Simple as that.
We are so close. The code is secure now. But hang on, there is one last absolutely critical step. That old, insecure version of the config file, it's still lurking in our Get history. We have to completely erase that digital footprint before we can push anything.
To do this, we need a special tool, a kind of time machine for our code. It's a powerful Git command called rebase. Git rebase actually lets you go back and rewrite your project's history. It's perfect for this. We can use it to find that one commit where we messed up and remove the secret keys for good, making sure they never see the light of day. Now, when you start an interactive rebase, Git opens up an editor that looks like this. It might seem a little intimidating, but it's really just the list of your recent commits. It lets you choose what to do with each one. Pick to keep it, edit to change it, or drop to just delete it entirely. We can find our bad commit, change pick to drop, and just like that, the secret is gone from history. And all of this brings us to a final, pretty important thought. Managing secrets isn't just about your code right now. It's about its entire history. GitHub might catch an obvious leak today, but what about a secret you committed last year? Your project's history is a public record. So the real question you need to ask yourself is, are you absolutely sure your secrets are truly private?